Hello. So today we are starting our first official lecture about environmental science, and really, in order to actually start talking about environmental science or all the aspects of it, you gotta kind of know what it is, right? What is environmental science? So I'm gonna try making this as quick and as succinct as possible, but environmental science is really just the study of natural systems and how humans both affect and are affected by those systems. Um, you know, kind of key here to understanding environmental science is the word, right? Obviously, when we think of environmental and science, we often think of just the environment and how it exists or how it's doing or the scientific concepts behind it. But probably about 50%, if not more, of that actually is human. How are those systems affected by humans? So even though we're discussing environmental science, a lot of it has to do with human interaction with the environment. That's really what we're discussing here. Thinking about these issues, we talk about global warming, we talk about pollution, whether it be plastic, we talk about, the destruction of ecosystems. Those are all human related, at least in the current outlook of the world currently right now. So when you're thinking environmental science, don't just think about simply the environment. It's about humans and our interaction with it as well. Environmental science is concerned with studying the environment, right? The environment consists of all the living and non-living things that interact with organisms. We're going to kind of go into this, but everything you can think of that exists here on Earth has to do with the environment or whatever is on the biosphere of the planet. Then we kind of delve into ecology, which is the study and the interaction between organisms and their environment, especially human interaction with their environment. Ecology is important to understanding environmental science, but it's only one part of the discipline. I want to really stress that. As we're going to see, often I think we think about the environment as this, you know, as this nature thing, trees, forest, animals, living things. But once again, and that is the ecological side of it, right? The study of those type of organisms. But what we really get into is systems thinking. That is what environmental science is all about, systems thinking and how humans are interacting and changing those systems. And we'll talk about that in much more detail as we move on to 1.2 and 1.3. Um, because the environmental science also deals with humans, the most anatomically and behaviorally complex animal on this planet, it is necessarily interdisciplinary. And this is a key term for you to know and will probably pop up in a quiz sometime. But interdisciplinary means that problems posed by environmental scientists must be approached with knowledge of multiple academic disciplines. So I'm reading it word for word on that, but just know interdisciplinary means it encompasses so many different subjects, so much different matter. We will that's why I have you do a math diagnostic at the beginning of this course, because it involves math, it involves statistics. We're going to talk about chemistry in this class. We're going to talk about biology. We're going to talk about economics and social sciences as well. We delve deeply into all those type of subject matters, right? And this is a good graphic that kind of shows that, shows the interdisciplinary connections of environmental science. Multiple fields of study, right? Just from this graphic alone, and I would say this is just a fraction of all the things we'll talk about. These probably make up the biggest parts, but just know there's multiple disciplines, right? So we have ecology, forestry, geology, engineering, chemistry, physics, mathematics, religion, even political science, sociology are all involved in environmental science. Why? It is how humans interact with the environment. Of course, even when it comes to religion, think about religion in a sense, right? Maybe the type of religion that you are in or that you know about, it has an effect on the environment. Think about the differences between Christianity versus Hinduism, right? Or Buddhism, or Judaism, right? Or Islam, right? All these different religions have different bases on how they interact with the environment. We will discuss that quite in depth, but just think about in many, in Hinduism, often the cow is seen as sacred, where cow has a big impact on the environment, on beef specifically, right? the meat consumed by these animals. So just know that, that's just one take religion, but just know that many different subject matters are included when we're talking about environmental science, and they're needed. That's why I like to really stress the point where hopefully all of you are taking this because you like environmental science, but I like to think of environmental science as the most important, obviously because I'm an environmental science teacher, but the most important because you have to be what kind of considered a Renaissance type of person, where it's just kind of this phrase of somebody who knows a lot of many different things. An environmental scientists, and in the class of environmental science, has to know many different takes on subject matter to understand these disciplines and these concepts that we will talk about. Economics, poor versus rich, the haves versus the have-nots, education levels, gender issues. We will discuss all those in this class. Population, all of them. All right, so moving kind of along. So these are just examples of how we'll use these certain subject matters in this class of environmental science. Now, of course, we're going to reach far past what I'm going to discuss here, but these are just some ideas. So let's say a community decides to use coal for electricity as its cheapest source available. That's economics. We're going to get into the economics of situations, right? Cheap versus expensive, and the give and take that those encompass. Then we might talk about the coal might get mined from under the soil. Then we'll have to talk about geology, right? The study of rock formations and how coal and oil form naturally. Then we might talk about the coal must be transported to population centers by road or rail. We're going to discuss engineering, right? Engineering is going to be huge in environmental science because we're talking about new technology, solar versus hydroelectric versus nuclear, right? We're going to get into engineering concepts. Then when it's burned at a power plant, air pollution is released. Some of that pollution is converted to acid in the atmosphere. Chemistry, we're going to break it down. You have to know for AP Environmental Science, you have to know the chemical breakdowns of just not only the pollutants, but maybe photosynthesis, those type of things in this class. Then acid rain then falls somewhere downwind. We'll talk about meteorology, right? Weather systems and how that affects ecosystems and the environmental science. Then we may talk about the acid stresses plants by affecting their nutrient absorption, which then we get into ecology and how they affect ecosystems and other species and organisms that belong in that ecosystem. And then we might talk about laws or passed requiring that plants to install pollutant scrubbers. This gets into politics, right? Making laws and legislation that we will deeply go into, especially being an AP course. We'll talk about a lot of American laws because it's an American kind of science, right? Or not science, but it's an American APs and environment in an American curriculum. So we will talk about American laws and how, and then we'll kind of translate those to how that is interacted within our own communities. So really to stress these points that environmental science, we're going to touch a lot of different subjects. Be ready to discuss and to talk about these different things. And hopefully you kind of, that's also, some of you might hate math or engineering or chemistry. So we are going to have to discuss them so you understand that. But then you might like the other things like meteorology, ecology, or politics and economics, or vice versa, right? So I like to think that at least you're going to find some aspects of environmental science that you're going to enjoy discussing in this class. Excellent. Okay. So now we're just going to kind of finish off my last point for this kind of lecture is obviously when we're talking about environmental science, we're going to talk about resource use. And natural resources are the materials and energy sources organisms need to survive. This is anything that you or I or a worm or a cockroach or a cricket or a lion or a tiger and bear, oh my, these are things that everything that those organisms use in their lives is a natural resource. So water, air, maybe even rocks. Maybe they live in a cave, so rocks are a part of it, right? And then kind of going on to that, other organisms that they eat is a natural resource for that. Let's use tiger for example. Maybe they eat antelope. Well, that's a natural resource for the tiger or lion that exists, right? So now think about even space. We can even consider space a natural resource. So because of the complex, but kind of before I move on next time, now start thinking about all the organisms and the natural resources that they may require. Now think about you. Think about me and the resources that we need. You're probably watching this on a laptop or a computer or your phone. Think about just that piece of technology. How many resources are involved in the construction of these technologies? You would be amazed. Plastics, metals, exceedingly rare metals in some cases, chemical processes, energy that is required for your computers. So many natural resources go into the making of your electronic device. Water, air, all these things, right? So keep that in mind, and that's just one aspect of it. Think about your daily life from when you wake up in the morning to when you go to bed at night. All the actual natural resources that you need to survive or to go about your daily life is insane compared to, let's say, a lion or a tiger or a bear or a worm or a cockroach, right? We just need, as humans, we need so much more because of our complexity. We need more natural resources than most organisms. Material for building and manufacturing, metals, woods, cotton, plastic, from oil, coal, etc. You can think of it. Arable land for agriculture. We just need lots more space than other animals need for our food, for our living. Just not our homes, our food. Maybe canals to build our water system. To going to school, to work. We need much more space than other animals do. Fresh water for plumbing and irrigation, and we won't forget about manufacturing. We're going to find out there's so much water involved in manufacturing. Going back to that electronic device in front of you, takes thousands upon thousands upon thousands of liters of water just to make that thing create that product that you have in your hand, and that one individual product. And then we need energy, right? Obviously, you needed to connect to energy, which is now stored in your battery or you have it plugged in. We need oil, coal, different types of electricity to power our machines, cars, computers, refrigerators, so on, right? So humans are just much more complex, and we take so much more of the earth than all the other organisms combined. And that's kind of what we're leading to is the main problem. So using these natural resources provide many benefits to humans, however, but come with environmental costs, obviously, right? And that's kind of where this is going to all lead to. Obviously, you've heard of global warming. You've heard of the plastic pollution problem. You've probably heard of biospheres crashing or ecosystems crashing due to humans because of our use, all of our need for stuff. It's not so much our areas. Technically, nature would probably be okay if we all lived in our cities and kind of didn't go outside the cities, but that's not where it stops. We need to go mining, we need to have agriculture, we need space for all those type of activities. So that's where the problem mainly comes into play. Using fossil fuels for energy releases large amounts of CO2 in the atmosphere, warming the planet. And then intensive agriculture can deplete nutrients and degrade the quality of soil. Those are going to be the two main examples that we're going to talk about throughout this year, but there's going to be so many that we actually will. And as we'll talk about in more detail later this year, simply acquiring these resources come at environmental costs. I think I kind of spoke on that, but just think of all the necessities that we need and all the complex interactions with the environment that they require just to get these type of things. So offshore drilling for oil can cause oil spills that wreak havoc on marine ecosystems. Mining operations sometimes contaminate groundwater with toxic chemicals leaching out. So, there's a lot of negative side effects of these things that we need on our planet. And kind of the last one I'm going to kind of leave off here is environmental scientists distinguish between renewable and non-renewable. We're really going to speak on this environmental in our course, in our year. Renewable resources are resources that are constantly replenished and essentially available at all times. Think of sunlight, wind, energy. They're always there. Hydroelectric power. They're always there, always moving, always giving us, the energy we need. Trees would fit actually in this category because they are somewhat renewable. We can cut them down, then regrow them, cut them down, regrow them. Corn, biodiesels, those type of things are renewable resources. Those are things that we can constantly keep replenishing. On the other hand, we have non-renewable resources that form so slowly that once they're used, they're essentially gone forever. Think of petroleum, coal, certain minerals. We only have a finite source of minerals on this planet. Once we dig out all the gold, there is no more gold, right? Unless we come up with some way of actually making that element, which we currently do not have the technology to do, right? So they're finite. There's only so much we can have. Maybe someday when we can start mining space, but we don't have access to that currently. And same thing with petroleum and coal. They take millions upon millions of years to form. They're essentially from old dinosaurs and phytoplankton that existed millions and millions of years ago that eventually broke down to form these structures, these elements, right? These energy sources. Um, they take millions of years. We cannot create more petroleum or oil or coal just like that. It takes millions upon millions of years. So those would be considered non-renewable resources. Um, so to kind of finish this point, but many natural resources fall somewhere in between fully renewable or non-renewable, right? Quickly renewing resources include fruit, vegetables, and other farm products. So those are renewable, right? Think about tomatoes. Every year, or rice or any other thing that gets on your plate, we can grow them, we cut them down, you eat them. Then the next year we grow them, we cut them down, you eat them, and so on. Those are renewable. We can keep that stock replenished to a certain amount as long as the environment allows it, right? But then there are more slowly renewing resources, which include forest, soil, and fresh water, right? These take a little bit longer. So, once again, like I put trees into renewable resources, but just know they're not as quickly renewing as some other ones. So just know there is this kind of level. What I would say for environmental science is kind of stick this in your head. If it can renew within a generation of time, I would probably put it in the renewable category. If within your lifetime, this product can reform, it probably goes in the renewable category according to AP Environmental Science. Same thing with IB. But this changes by us environmental scientists, right? We nobody can completely. There's not like a set time limit of what's considered a renewable versus non-renewable. Just keep that in mind. If we can essentially regrow within a lifetime, it's going to be in the renewable category. Okay. All right. Yes, I'm going to stop there. I'm not going to move past there, but that is it. Hopefully you got mainly the first half of what environmental science is, and we will move on in the future. Enjoy the rest of your day and just, relax, have fun, live your life.